Okay, on the recursive and special sequences, I need you to read this before you get started. I don't need to read it out loud, I don't think. And we're going to do 2 problems, and I'm going to give you a paper to do the same thing that I did. So you should read this, look at my 2 examples I do, then come back and read this again. Read it the second time. Okay? So basically, we have an example here where we have to find the first 6 terms of a sequence, and they give you f of 0 equals 4, and they give you the formula. So they're giving you the parts of the formula, the value of the first term, and a recursive equation that shows you how to find each term from the terms before it. Okay, so we have to find the first 6 terms. So basically what we want is, what they're looking for is f of 0, f of 1, f of 2, f of 3, f of 4, f of 5, and f of 6. Oh, just f of 5. This would be 6 terms. 1, 2, 3, 4, 5, 6. So there's your 6 terms. So basically we already know that f of 0 equals 4 because they gave that to you right here. Now we're going to use this formula to find the others. So to find f of 1, we're going to let n be 0. So for f of 1, I'm going to write f of 0 plus 1, because that gives you f of 1, equals f of 0 plus 3, because my n is 0. Well, what is f of 0? We're using the previous term, so that's going to be 4 plus 3. That equals 7. Okay? So to find f of 2, we're going to let n be 1. I'm using this formula here again, that part. So my n is 1, so I'm going to do f of 1 plus 3. Well, f of 1 is 7. So I have 7 plus 3. That gives me 10. All right, for the next one, I have f of 3, so that's going to be n is 2 plus 1 equals f of 2 plus 3. And f of 2 was just 10, so I'm going to get 10 plus 3 equals 13. All right, we have f of 3 plus 1 equals, let me erase this, this bothers me. All right, f of 3 plus 3. Well, f of 3 equals 13, so I get 13 plus 3 equals 16. And again, I did this little thing here. And now the last one is f of 5, so I'm going to let m be 4. That gives me f of 4 plus 3. F of 4 equals 16, so I get 16 plus 3, and that gives you 19. And that's basically the simplest that you can get on that. So that's a recursive formula. You're using the initial term and the recursive term, the recursive equation. Okay, another special kind of recursive formula is called iteration. All right, so they give you a formula, and they give you initial value. Now, the initial value really is x to the 0, and I left a little room there, and I can't write it. Whoops, sorry. Let me erase that. So this is basic. Let me just write it down here. X to the 0 equals 1. All right, so I didn't have room to write that. So basically, they give you the x equals 1. The first term, the initial value is x to 0 equals 1. So, and they want the first 4. So we have f of x to the 0 equals f of 1 Here's my formula, and I'm just composing it within itself. So that's 3 times 1 plus 5, which equals 8. And now I'm going to do the second the value, which would be x to the 1. So that's going to be f of 8. Okay? Because I'm using the 1 here to go with this one. So f of 8 equals 3 times 8 plus 5 equals 29. Okay? Okay, f of x of 2 equals f of 29, because that's the previous value. And that's going to be 3 times 29 plus 5 equals 92. And then we have f of the second iterate equals f of 92 equals 3 times 92 plus 5, which equals 281. So we're just composing the function within itself over and over. And you take the previous term and keep plugging it back in, and that's all it is. Okay? And that is all.